Well, let x be a random variable with a probability density function given by f of x equals cx squared when the size of x is less than or equal to 1 by absolute value and 0 otherwise. We need to find the constant c that makes this a probability density function. We want to find the probability that x is greater or equal to 1/2. All right, well, let's start with our constant c. We know that the integral from negative infinity to infinity of f of x needs to equal 1. Well, this function is 0 anytime x is outside of -1, +1. So this tells us here that we're cx squared when x is between -1. Oops, that's an x. So whenever x is between -1 and 1, we have cx squared, and we have 0 otherwise. So this is equal to the integral from negative infinity to -1 of 0 plus the integral from -1 to +1 of cx squared plus the integral from 1 to infinity of 0. And of course, the first and last integral here simplify to 0. So we have the integral from -1 to 1 of cx squared dx. Antiderivative of cx squared is cx cubed over 3. And that's evaluated from -1 to 1. And so we get c over 3 minus, plug in -1, a negative c over 3. So this is 2c over 3. And of course, it's equal to 1. So c needs to be 3/2. Okay, so given that c is equal to 3/2, we can now find part 2, the probability that a random variable x is greater or equal to 1/2. So this is the integral from 1/2 to infinity of f of x dx. And of course, we saw before that when x is greater than 1, that integral is 0. So this is going to be the integral from 1/2 to 1 of f of x dx plus, of course, the 0. And this integral then is the integral from 1/2 to 1 of cx squared, and c is 3/2. The antiderivative here is going to be 3/2 x cubed divided by 3. So the 3's will cancel. So we'll end up with 1/2 x cubed evaluated from 1/2 to 1. We plug in 1, we get 1/2. When we plug in 1/2, we get 1/2 cubed is 1 over 8 times 1/2 is 1 over 16. So 1/2 minus 1 over 16, which leaves us with 7/16. And that's the probability that x is greater than or equal to 1/2.